gradient descent. And what is the cost function that we use for this is, so yeah, again, if you, so this is basically the cost function, right? And this is what we have to minimize. And if you are looking for a derivation of this function, I have just explained it in the previous lecture when I was doing the naive Bayes algorithm. So please go through that lecture if you want mathematical derivation of it. Right? But here I'm just explaining what the terms means again. So for example, let's say you have some, yeah, as I said in the previous example, you have some mice and some are classified as obese and some are classified as non-obese. So y is the y value, like whether it is obese or not. So if it's obese, then y will be 1. Not obese, y 0, right? So y times log of h theta x. So h theta x is basically your prediction. So this is this logistic model, this value of the sigmoid function, the value of p basically that is given here. 1 divided by 1 plus e to the power of minus b naught plus b1 x, right? And yes, similarly, if you have more features like other than weight, if you have like, size or something else, you would have like b naught plus b1 x plus b2 y. Sorry, b2 y is a bad choice of variable. b1 x1 plus b2 x2 plus b3 x3 and so on. Like whatever the number of features that you have. Right? So yeah, so h theta x is basically that p value, right? And minus 1 minus y log of 1 minus h theta x, right? So, yeah, any questions on this? So this is, so in case of linear regression, if you remember, we use the least square cost function, right? And then we applied gradient descent on that least square cost function. Here, we are applying this cost function, which I derived in the previous video, and we are trying to minimize this cost function and then find the values of this. So here I have written b naught b1. So these are basically theta parameters, theta naught or theta 1, whatever you say. This is just naming. So we want to find those theta naught theta 1 or b naught b1, and then we want to find, then we'll find this p value, and accordingly, as I said, we can classify them as obese or not obese, right? So is the concept clear? Is the whole process that we are doing, is that clear from a conceptual point of view? We'll go into the mathematics, but is the concept clear before that? Okay. Okay. So yeah, you can ask me questions like if you are, stuck at any part or you need more clarification. So how do we minimize this cost function? Again, we use the gradient descent method. Yeah, so basically what you do is whenever you want to minimize some function, what you do is you take derivative of that function. So the derivative, and you equate the derivative to 0. So that will give you a minimum of that function, right? So, and then, but in in this algorithm, gradient descent algorithm, which again I have explained in one of the earlier lectures, is what you do is you update this theta parameters, whatever theta parameters that you have. For example, b naught or b1. In this case, you have only two parameters, b naught and b1, or you can say theta naught and theta 1, right? So you update those parameters. You start with some initial value of theta naught and theta 1, and you update them by using this function, right? So theta naught minus alpha del j del theta, right? And you iterate this till you converge to a minimum, right? So here are questions like, you know, how would you know whether you have converged to a minimum? And another question is, what is this alpha? Alpha is called the learning rate, right? So, yeah, again, these two questions I have answered in one of my previous videos, but I will just quickly, explain them again. So, how do you know whether you have converged to a minimum, whether your theta has come to a minimum? So you can understand that by seeing that, okay, so after some iterations, your theta would not change by very much. Your theta would remain, let's say, would change by very small amount. And then you know that, okay, my theta is not changing much, so I have converged to a minimum. So that is the way to know whether you have converged to a minimum or not. And secondly, what is alpha? So alpha is the learning parameter. So this will determine how fast you are converging to a minimum. So for very high learning rate or learning parameter, what we will do is that you will take bigger steps towards the minimum of the function. Whereas for small alpha, you will take smaller and smaller steps towards the minimum. So smaller alpha would, increase computational time, whereas bigger alpha would reduce computational time, but at the same time, it will, uh, it might have some chances of uh, not converging. It might diverge as well, right? So again, please go through the previous lectures uh, to know about these answers in more detail. Okay. So yeah, so basically you repeat this and you find the optimal value of theta naught and theta 1, and you find the value of p, and from there you can classify whether this is 0, y is equals to 0 or y equals to 1. Now, uh, okay, so let me, so I will do the calculation in a minute, but if you like take the derivative of j with respect to theta, you get this term. But like how did this term comes in, right? So I'll just do the calculation of how del j del theta is this value, right? So again, let me come back to my notepad. Yeah, in the meantime, if you have any questions, please ask me. So it is gradient descent algorithm. So the algorithm is theta j is theta j minus alpha times del j del of theta j, right? So what is your cost function? The cost function is minus yi log of h theta xi h theta xi minus 1 minus yi log of 1 minus h theta xi, right? This is your cost function. And what is your h theta? H theta xi is 1 divided by 1 plus e to the power of minus theta transpose x, right? So that is the sigmoid function that we saw, right? This is called the sigmoid function, which has that S kind of shape, right? Right? And it has values between 0 and 1. Okay? So this is a theta with respect to x. Okay? All right. So what is del j del theta? This term that we have to calculate. This is the term that we are calculating. Del j del theta. So what is del j del theta? So we are taking derivative of this expression. Okay. So it is minus yi. So derivative of log is 1 by x. So h theta xi times derivative of h theta with respect to theta. So this is just chain rule, right? So I think everybody understands this, or do you need any clarification? Let me know. So I'm just applying chain rule here. Okay. So minus 1 minus yi. Again, derivative of log is 1 by x and del of h theta del theta. Right? Right? Okay, so one thing here there will be 1 minus, so del of minus h theta. So if you see, we're taking derivative of minus h theta, right? So here is the minus sign that we have, okay, in the expression, right? So because of this minus sign, we're taking derivative of this. Because of this minus sign, another minus will come, and this will be minus h. So this minus minus will become, actually it will become plus. Okay, so this will be plus, right? Okay. Now, one thing that we have to calculate is del of h theta with respect to theta, derivative of h theta with respect to theta. So basically, then we'll consider this line. We'll take derivative of this h theta. So again, 1 by 1 by x is minus 1 by x square. That is e to the minus theta transpose x whole square times derivative of e to the power x is e to the power x times derivative of theta is x transpose. Okay. And here again, there is one minus sign, which will cancel with the minus that we got from here. So again, so I'll just write this explicitly, but this minus minus would become plus. So one minus coming from derivative of this, another minus coming from derivative of 1 by this thing, right? So I'll just do it plus, yeah. So this is the expression, right? Now, this can be written as h theta square. Okay, let me. So what is this term? This term is basically h theta square, right? If you see h theta is this thing, this is just square of that times e to the power of minus theta transpose x times x transpose, right? We can like write it like this. Okay. Now, in other words, you can also write e to the power of minus theta transpose x as okay. Wait, we will do it. We'll do that later. Let me let me rewrite the del j del theta term. Okay. So from here, we see del j del theta would be minus of yi times this 1 by h theta that was there earlier times del h del theta. So del h del theta we got as h theta square xi times e to the minus theta transpose x times x transpose. Okay. So I'm just substituting del h del theta over here. Plus 1 minus yi Mm, Okay, Valli has raised a hand. Yeah, please. Is there a question? Okay, if not, let me proceed. So 1 minus yi times 1 by 1 minus h theta. Wait a minute. Yeah, 1 minus h theta xi times again del h del theta. So that is h theta xi square, h theta square, e to the power minus theta transpose x times x transpose. Okay. Now we will see what is 1 minus h theta. 1 minus h theta is 1 divided by 1 plus e to the power minus theta transpose x. That will give you e to the power of minus theta transpose x divided by 1 plus e to the power of minus theta transpose x. So that is basically e to the power of minus theta transpose x times h theta, right? Okay. So far, so good. All right. Now we'll just substitute uh, 1 minus h theta in this part, this region. Okay. We'll substitute this value and this over here. So again, from here we get del j del theta equals to minus yi. So if you see 1 h theta and 1 h theta cancels, so basically h theta xi times e to the power minus theta transpose x times x transpose, okay, plus 1 minus yi, 1 divided by, yeah, we are replacing 1 minus 1 minus h theta with this thing, h theta xi times h theta square xi e to the power of minus theta transpose x times x transpose. Okay, we're just replacing that. So if you see e to the power of minus theta transpose x cancels with e to the power minus theta transpose x, 1 h theta cancels over here like this, and you will have minus yi h theta xi e to the power minus theta transpose x x transpose plus 1 minus yi. What is remaining is h theta xi x transpose. Now, there is another manipulation that we have to do. Okay, so I'll write it over here. So if you see that h theta equals to 1 divided by 1 plus e to the power of minus theta transpose x, right? So basically you multiply it. So 1 equals to h theta plus h theta times e to the power minus theta transpose x. So from here you will get e to the minus theta transpose x equals to 1 minus h theta divided by h theta. Okay. So I think the ink is little bit lower. Let me, okay, let me write it properly. So h theta equals to 1 divided by 1 plus e to the power of minus theta transpose x, right? So simplifying this, I will get h theta plus this thing, okay? And from here you can get e to the power theta transpose x equals to 1 minus h theta divided by h theta, okay? And Now we'll just substitute e to the power minus theta transpose x value over here. So this is h theta times 1 minus h theta divided by h theta x transpose plus 1 minus yi h theta x transpose. Okay. So again, this h theta cancels, and you are left with minus yi 1 minus h theta x transpose plus 1 minus yi h theta x transpose, right? So this will give you minus yi x transpose minus h theta yi x transpose plus h theta x transpose minus yi h theta x transpose, right? So h theta yi x transpose cancels.